Hey, it's us again, or at least our hands.
My hand again, too.
There we have it. So this is, I call these arc problems. In this problem, the ball is going to leave the ground with it's 78 degrees, so it's going to leave the ground with some velocity like that, okay? And it's going to follow a path kind of like that and hit the ground, okay? And the key to this thing is that, I mean, the good news is we're going to use the same exact thing that we did before. But the only trick here is that we've got to get into this problem, we've got to break this guy into components.
You got to know what the x and the y are. So the first thing is to label your original vector. And we got a speed of 41.3 meters per second and an angle of 78.2. So now we've got to use our SOHCAHTOA skills and break those into components. And in this case, our x is going to be adjacent. So we got to ask ourselves, is that one x or y? Well, it's x, and is it positive or negative? It will turn out positive. And then we got to ask ourselves if it's sine or cosine. Since it's adjacent, it's cosine. So we'll go ahead and it looks like Mr. Murray already figured out what that was.
Yeah.
That's.
So I'm going to write down 4 digits here. Here they're giving us 3, right? So I'm going to write down one more digit. So 8.44. I'm going to say 6.
Yeah, for right now.
Meters
When we
per
report it at the end, we'll change it. Okay.
And then 41.3 sine of.
Remember, with that component, we're asking ourselves, is it x or y? Well, the other one's y. Is it positive or negative? Well, it's positive. It's going up. And it's going to be using the sine, and 41.3 times sine 78.2. That's going to be 40.2.
This is what I did, 78.2. Right, so now these things go in here right away. So when they give you a launch angle, you immediately know these guys, right? So the horizontal is 8.446, and the initial vertical is 40.427. Now, all the things that are true about from now on are still true, right? So this guy is 0. That makes this guy the same, 8.446. Right? This is negative 9.8. Okay. And then in the vertical direction, since this is going up and down and landing at the same elevation, there's lots of things we can do. We can say that that's 0, but that's not very helpful. In other words, we end and start at the same elevation. There's no change in elevation. But this is the key thing. And if you remember these problems where you went up and down, that's all it is vertically, right? The key here was that this was negative 40.427.
We're talking about the point right here. If it's going to be positive 40.4 here, it's going to be negative right before it hits the ground.
Right.
And that is awesome. That gives us a lot of leeway here.
So basically, if you remember on these things, to figure out the time that it's in the air, we're going to use this guy. The VF is VI plus AT, right? So negative 40.427 equals positive 40.427 plus negative 9.8. Oh, I should have thought ahead, right? Times T.
Now, people that are bad at math think, well, T must be 0 because that's going to cancel out. No, we have to subtract it from both sides because it'd be like negative 80 point something.
So if you look, we're going to put this on this side, and then it's going to be twice 40.427. So I'm just going to
subtracting 44.427.
So if you look on the calculator, that's 80.85, and then I'm going to divide by 9.8 to get T. Okay. To that. And I'm getting that it's in the air for 8.250 seconds.
Now, if this was an actual golf shot, that'd be kind of crazy.
Yeah.
I mean,
I'll bet there's golf shots like that.
Well, yeah, but you don't want that for a drive.
Yeah, probably not so much.
Yeah, a chip maybe.
Okay, so here we go. And then the same thing, we can castle that guy across. So 8.250 seconds, right?
Time goes on both sides.
And then we can go, and the only thing we ever do horizontally is we only ever do what X is V times T, right? Or V is X over T or something like that, right? So I'm just going to multiply this by this. So I'm going to go times, it's already on my calculator, so I go times 8.446, and I get 69.7 meters over.
It's
So
definitely a chip shot.
yeah, definitely, right? Okay, so the time it's in the air, about 3 seconds, I guess we'd have to say, right?
Yeah.
Or actually, we can say 8.25 because they're giving us 3, right? The horizontal distance it travels is 69.7.
Don't forget units.
Oh yeah, Mr. Duggins correcting my units there. So 69.7 is that, right?
Mm-hmm.
And then there are these tricky questions. What's the speed at the highest point of the ball's trajectory, and what's the greatest height? And the key there is, I mean, we have to redo the whole thing, but remember at the top it's only moving horizontally. Now, do you have any guesses, Mr. Duggan, as to what the horizontal velocity is at the top?
I would say it's this
Exactly.
because it stays the same all the time.
Its velocity, so at the top, the vertical velocity is 0, and the horizontal velocity is what it always is. If you look at it any place in its trajectory here, it always has this horizontal velocity. So at the top, the speed at the highest point is 8.45, I guess we'd have to say. And I'm just rounding that to 3 digits, okay? So 8.45 would be our speed because that's its horizontal velocity, right? And then it says, what's the greatest height? Well, I think we've got to like redo this guy, right? So let's do another one here. Let's go X, VI, VF, A, and T, right? The final velocity at the top vertically is?
Final velocity at the top is 0.
And
Does
the
this
initial-
kind of remind you guys of the rocket lab?
Yeah, exactly.
So isn't there something that we ought to be maybe doing with this time?
You
This
could
is
cut the time in
whole
half.
time in the air. So if you cut it in half,
You can do that too. I always just do this. I always just say that's 0, and then, I don't know.
yeah, it's up to you, the individual problem solver,
That's right.
to decide. Now, you see Mr. Murray's going to go VF equals, VF squared is 2A delta X, because if we know these two things, that makes it awesome, and we can solve for X that way. If you cut it in half, then you could use some of the other equations too.
Right, so
This
you
is
could-
probably the easiest.
You can cut the time in half, but it's just then it gets rounded, is the only thing.
Yeah, that's a bummer.
So I'm going to go 0 squared is, 40.427 squared plus 2 times. Right, so it's going to end up
It's just a
being
matter of crunching numbers now.
so 44.427 squared, I think, divided by 2 divided by 9.8 roughly. And it's not negative because you put this on this side, right? So I'm getting 83.4 meters is the greatest height. So that's really a separate question. You just make the final vertical velocity 0 and you're set, right? And then the speed at the highest point is it's tricky, right? It's just the horizontal velocity.
Yep. And what this 83.4 meters represents is this. It's the height to that type at the top.
Yeah. I don't think there's anything else to say.
Nope, we're done.
I think we're done. Oh, the code word?
Oh, code word for this one is going to be chip,
Chip.
as in chip shot.
Chip shot.